For this video series, I believe I have written 5 combination questions representing just about the entire spectrum of possible combination questions they can ask you on the GMAT. But what I want to emphasize from the start, from this first and most important video in the series, is that really there are only 2 types of combination questions. And if you can understand these 2 types of combination questions from the bottom up, you can understand these 2 concepts conceptually, you should be able to see that every other type of combination question is simply a variation or an application of these 2 fundamental types of combination questions. So if you should, what do I mean when I say from the bottom up? So that's opposed to top down. Top down would be something like using formulas or shortcuts. Bottom up means simply understanding them logically. So we will try to do these first 2 questions without any sort of formula or anything. So to introduce our 2 types of combination questions, let's start with a question itself, because it is the question I ask myself when I see a combination scenario. That is, does order matter? It is the first thing I do when I get a combination question. So that sort of spoils what our 2 types of combination questions are. We have ones where order does matter, and then we have ones where order does not matter. So why is this an important distinction to understand? So let's start with order matters. So what would be an example of an order matters scenario? That would be something like running a race. So let's say I have a bunch of people competing in a race. I have A, B, and C, then a bunch of other people. And I want to know how many ways I can range these people in first, second, or third place. And so let's talk about some examples. And so one example is I can have A finish first, B finish second, and C finish third. And so I would want to include that in my possible combinations. What's another combination? Well, I can also have A, then C, then B. And because in a race order matters, ACB, meaning A first, C second, B third, is a totally different combination than ABC. And both of those are totally different than BAC, which is totally different than BCA. And so I want to count all of these. I would also want to include CAB and CBA. In a race, when order matters, everything counts. And so that means when order matters, that is really the simplest scenario, because you do not have to get worried. You don't have to worry about getting rid of any duplicates. You don't have to take out any of your repeats. It is a one-step process. Everything goes in the pot. Contrast that with an order does not matter scenario. So what would this be? This would be something like you're just picking a team or picking a committee. And this is how I will literally think about a combination question. If it's unclear whether order matters or not, I will think to myself, well, am I running a race or am I picking a team? And so in this scenario, let's say we have the same pool of people, A, B, C, and a bunch of other people. And I'm choosing 3 of them to be on my committee. And I want to know how many ways can I pick these 3 people? Well, in this case, ABC would still be one example of the 3 people I can choose on my committee. But if I'm choosing a team where order does not matter, ACB is the same team as ABC, which is the same team as BAC, which is the same as BCA, and the same goes for CAB or CBA. And so I would not want to count all of these committees because they are all the same committee. I would still want to count them once. But once I've done that, I do not want to count these guys. And so when order does not matter, it is usually a 2-step process, because usually you have to find your number of combinations with your repeats included, and then you have to take out the repeats. And so with that framework in mind, let's take a look at an example of each of these. So first we have an order matters scenario, which I said before, that should be the simplest type of combination question. And so in this case, 10 horses are running a race such that the first place finisher receives a gold ribbon, second place receives a silver ribbon, and third place receives a bronze ribbon. How many different ways can these 3 ribbons be awarded? And so once I ask myself, does order matter or not, the next thing I like to do is write out my pool of candidates, which I am choosing from. We got 10 horses here. We can call them A, B, C, D, E, F, G, H, I, J. That's 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's my pool. And then I'm choosing 3 of them. So how many options do I have for who can finish in first place? Well, I can choose any of my horses, right? And so I should have 10 options here. Now, once a horse is chosen for first place, it can be any of the horses, but once one of those horses is chosen, how many options are remaining for second place? Well, you should only have 9 options left. And then the question becomes, well, if I'm counting my total combinations, do I add these guys or do I multiply them? And you should be multiplying them, because what you are saying is any of these 10 horses which can finish in first place can be paired with any of the 9 horses that can finish in second place to give me 90 total 1-2 combinations. And then any of those 90 1-2 combinations can be paired with any of the 8 remaining horses to give 720 1-2-3 combinations. And this is our answer. We don't have to do anything else. Every single combination counts. And so this question, if I were to see it, this would take me about 15 seconds. 10 seconds to read the question, then 5 seconds to get the answer. So now let's look at a similar scenario, a similar sounding scenario, but fundamentally different. 10 candidates are interviewing for a job with 3 openings. If the company plans on filling all of the openings, how many different ways can the candidates be selected? And so in this case, I'm just picking a team, right? So order does not matter. Now my pool, I can use the same pool as before, right? I just got 10 people. Now, I don't have horses. These represent people, unless you're interviewing horses for your job, but most likely not. So, but I will give them the same labels. So now in this case, let's start by doing the same thing we did before. So we have 10 options for who can fill our first spot on our committee, or not our committee, for our job opening. Then we got 9 people remaining who can fill our second job opening. And then we got 8 remaining for our third opening. And that gets us to 720. But as you can probably guess, that's not our answer here. Our answer should be less than 720. So if this is where you started, one thing you could do, if you weren't entirely sure to calculate the exact answer, you can at least say, oh, well, it's got to be less than 720 because this is my answer with my duplicates included. This would be if I was including ABC, BAC, CBA, etc. So how do I get rid of my duplicates? Well, the way to think about it is for any given team of 3 people. So let's say the 3 people I chose were in fact A, B, and C. Doesn't have to be. Could have been A, B, and D, B, E, and F, H, I, and J. It doesn't matter. But let's say the 3 people I chose were A, B, and C. Well, how many ways can any given team of 3 people be arranged? So if this is my team here, A, B, and C, I got 3 options for who I could have chosen for my first slot, 2 for my second slot, and then 1 for my third slot, which will give me 6 possible ways this team or any team can be arranged. And we actually already calculated this before when we wrote out all our possibilities, right? We had 6 ways, and this is, in fact, all of the ways this group of 3 people can be arranged. And so since for any given team, we can arrange them in 6 ways, that means when we calculated this 720, this number is 6 times too big. It is 6 times more combinations than what we want, because we only want unique combinations of 3 people. So our answer is really just 720 over 6, which is 120. And this is something you should have noticed maybe, is that when order doesn't matter, your answer should always be less. You should always have less combinations when order doesn't matter than when order matters. And so we were able to do both of these questions without any formula, without really memorizing anything, simply using fundamental principles and logic. Let's talk about the formula though for a second, because once you understand how to do these, I have no problem using a formula as long as I am not dependent on it, if it saves time, for example. So the formula that people are usually taught, and that sometimes I think is complex, is this. And so I think of it, this C here stands for choose. So I think of this as x choose y. And that would be equal to x factorial over x minus y factorial times y factorial. So in this case, I have 10 people and I want to know how many ways I can choose 3 of them. So that would be 10 choose 3. And that should be equal to 10 factorial over 7 factorial times 3 factorial. The 7 factorial just comes from 10 minus 3. And so let's look at what this formula is doing behind the curtain. So let's start by just looking at this portion here. So 2/3 of our fraction. What is 10 factorial over 7 factorial? So 10 factorial should just be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 7 times 6 times 5 times 4 all the way down to 1. And then these guys here, our bottom entirely cancels out. And then most of our top cancels out. We are left with just 10 times 9 times 8. In other words, this whole portion of our formula, all that it is doing is getting us to our answer with our repeats included, because this is our 720, right? And so you can think of our 720 here in 2 different ways. That is the answer. That's the number of combinations when order matters, or it is the number of combinations when order doesn't matter, but with our duplicates still included. And so if this gets us to our answer with our duplicates still included, what do you think this portion of the formula is doing? It is getting rid of the repeats. And sure enough, what is 3 factorial? Well, that is what we divided by. It's 6. And so this thing here, this 3 factorial or this y factorial, this is really the entire reason that this formula exists. It exists to get rid of repeats. And if you don't understand the formula, you might not realize that that is all this complicated formula is doing. And so what does that mean? When would you use this formula? You should never misapply this formula, because you should only use it in situations where order doesn't matter, because that is the only situation where you should be getting rid of repeats. If order does matter, I'm not using any formula. I'm just saying 10 times 9 times 8, boom, done. Some people have told me that they know 2 formulas, and so when order matters, they use sort of this modified formula, and then when order doesn't matter, they use the full formula. But that to me shows that that person doesn't really understand combination questions, because I would never use a formula for order matters questions. That's way harder than just simply understanding everything counts. Don't have to divide by anything, because you don't have to get rid of your repeat. 10 times 9 times 8, done. I'm not thinking about factorials or anything like that. And so everything we do from here on out is either going to be an order matters question or order doesn't matter question. And everything else is just going to be a slight twist on those concepts. And so let's take a look in our next few videos at some of those.